Hi, my name is Gad Rosental, and I am a group architect in the engineering department. With me is Roie Mandler, who is a development group manager. We work together with the teams that design and develop the Zerto Virtualization Manager, the ZVM. We love beautiful cars, don't we? They're exciting to look at. They look very well. But actually, it is the engine, the internals, the roar of the engine that excites us. And today, we're going to look and we're going to take a peek to the underhood of the ZVM so that you will know better of how it operates. We will start by reasoning about the ZVR architecture and the role of the ZVM in it. Then we will talk about some general things that are correct for the ZVM. We will continue on to see what happens and what does the application does when we do not interact with it, because it does many things. And then we will look at what does it mean to create a protection group, and then we will look at what do we do, some of the internals of what do we do through the recovery operations. So let's start off by looking at the ZVR solution and the ZVM within it. So basically, on the basic of it, we have a production site and a DR site. They are connected through a VPN, right? And then we have VRAs installed on those hosts that we want to protect assets at, or on the recovery side, that we're going to use as the recovery hosts. And this session focuses on the ZVM. So we know that we have on each of the sites one ZVR installed, and it is communicating with the virtualization environment. And then we install VRAs on the hosts. Now, you will install VRAs according to your needs. It can be that on the production side, for example, you will have only few VRAs according to what you're protecting. At the same time, on the recovery side, you will have, it can be, for example, that you will have dozens or even hundreds of VRAs because you're accepting loads from different sites. So there is this flexibility within, and that is related to your configuration of the protection groups. And as we configure the protection groups more and more, then we have these connections that appear between the VRAs, between the two sites, and through these connections, we replicate the data that is being changed, and it is being protected by the ZVM and the ZVR. So, by the way, I wanted to say that do take into account that there really isn't a production side and a DR side. Yes, we do have a production side and a DR side, but that is correct per a protection group. It is not correct entirely. You can have production loads on the left side and production loads on the right side, and you will be, and both sides can recover according to your configuration, right? So both ZVMs act both as protecting and as the recovery site for it. So we see that this is a solution with this configuration and the multiplicity between the ZVM and the VRAs. It is a solution that is designed to scale out. So let's move on and talk about these concepts that I mentioned. So let's talk about what are the responsibilities of the ZVM. So first, the ZVM executes workflows, and within the ZVR solution, the ZVM is the management and orchestration component. We install VRAs through the ZVM, and we configure the replication, and it manages and monitors the replication throughout the lifetime, and it validates, and you will see that, how it validates that the replication and the protection is being kept intact. Then we use the ZVM, of course, to execute the recovery operations when required. Also, another thing that maybe you don't know is that the ZVM is the application server that serves the pages that we see when we operate again with it. It is the ZVM that gives out these GUI pages. And one more thing that to be said is that the ZVM is the component that conceptualizes the protection groups. And I say that because actually the VRA works at the level of volumes. We configure and manage things through protection groups, and the ZVM digests it for the VRAs which operate on the volume level. Another thing that I wanted to tell you is that most of the operations that we operate on the recovery side, on the DR side. We will see more of that later when Roie will explain about the internals of the operations. Yet, we can operate the UI from both sides, and we will see the same things on both sides, and we will also return to this subject further on. When the ZVM starts up, it communicates with the virtualization environment that it operates in, whatever that will be, whether it's vSphere or whether it's a public cloud or vCloud director and so on. Then it will connect with its peers. When connecting with the peers, we start synchronizing information between the sites. The ZVM will send to its peers information about general configuration, things as where are the cloud connectors, which VRAs and on which IPs these reside, issues as licensing. After doing that, we will start synchronizing information about the protection groups. Although both sites will always maintain the configuration of a protection group, while being disconnected, it can happen and you can modify some aspects of the protection group. So when we synchronize, we will synchronize the information of that protection group or all protection groups between these two sites so that they will have the same shared equal information. As we do that, we also synchronize. The ZVM works and synchronizes, connects and synchronizes with the VRAs that is on its site. By doing that, the ZVM instructs and sets the state the VRA will operate with. For example, it instructs the VRA to which are the protected volumes that it needs to follow up and send information for. And it also says who is the VRA that is responsible for some protection of some volume. On the recovery side, we instruct information as such as what are the journals, what is their configuration, what is the length of history, where do the recovery volumes resides, and of course we tell each of the VRAs where can it find its peer VRAs. So we do that when we synchronize with the VRA. After doing that, we start inserting the checkpoints. That happens throughout the lifetime of the ZVM. Now, we do remember that the VRAs are the components that continuously replicate the changes that happen in your production environment. But it's the insertion of the checkpoints into the journals that sets the beat and allows us to provide low RPOs. Platform agnostic. That's another aspect of the ZVM. So what does it mean to be platform agnostic? Well, we know to operate with vSphere or vCloud Director, SCVMM, and the public clouds. We have a two-way translation with the external environment. We have implementations for all the APIs, the different APIs that are exposed by this virtualization environment. They expose different APIs, and they don't expose the same functionality. What we do is that we know their API, we have implementation for all of them, and we read information from them. We translate them into our internal representation. We operate the ZVM, and when required, throughout operations that we do, we will bring up or down VMs, we will reconfigure the IP, we will move disks, or we will create disks, which means that we will execute operations on this virtualization environment. And this is why I said that it is a two-way translation. By having these implementations, we can offer a cross-technology replication between the different types of virtualization environment. Another characteristic that is very important is our transactional behavior. So of course, we must operate through transactions because we always need to be in a valid state. So when we execute anything, the end result will be that we will be in a valid state. So we have transactions. So why do I bring it up? The reason is that our transactions have some uniqueness to them. What's the uniqueness within the transactions of the ZVM? So with the fact that the protection group spans over the two sites, so actually when we do any operations, we operate between the two sites, and two ZVMs are involved in this operation. So a transaction in the ZVM will mostly require two sites and two ZVMs to operate. But it doesn't stop there, because if we execute any changes on the virtualization environment, then it's also involved in the transaction. And let's mention the VRAs, because the VRAs are also involved in that. So the ZVM orchestrates its workflows, and through orchestrating the workflows and the steps in the workflow, we execute through a transaction that spans all that we've just mentioned. The way that we do it is, apart from executing these steps, we know to reverse the steps. So if required, what we will do is that we will reverse the steps that we had in the transaction, and this is how we have implemented it. I want to give an example. So this is somewhat of a specific example that is specific to the hypervisor and to the vSphere environment. In this environment, the VRA on the recovery side is, of course, a VM. Now, what I'm going to explain here is the orchestration of a specific transaction that we have on the recovery side in the vSphere environment. So what happens is that the VRA is connected and is accepting and writing to the recovery volumes on the recovery side, right? But one VRA can protect multiple protection groups. But, of course, each protection group must be separated and should not affect in any way another protection group. So that is, just to mention, the granule of transactions in the ZVM is usually at the protection group level. Okay? So it can happen that one VRA will be connected to some recovery volumes that span more than one protection group. Now, the difficulty, and the reason that we had needed to create this specific transaction is that when you have in the vSphere environment a a VM that is connected to some volume, and you need to storage vMotion that volume into another data store, then during the transition and the storage vMotioning from one data store to another data store, the VM that is connected to it is locked, and it cannot execute other operations. But the VRA is protecting multiple protection group. So what we did is we created a transaction where what we do is we create another VM. We call it a shadow VRA. It has a short-lived lifespan. And what we do is at the start of the transaction, after bringing up this VM, we connect the recovery volume that needs to go to the other data store, we connect it to the shadow VRA. Now that it's connected to the shadow VRA, our original VRA is no longer in the jeopardy of being locked down. So now we can storage vMotion it. So now it's on the correct location where we need it after this operation. Once we have it in the other data store, we are no longer in the question of locking down the VM of the VRA, and we can reconnect that recovery volume to the original protecting VRA. Doing that, we are no longer interested in the VM, and we delete it. And that's the transaction. Okay? Now imagine that all the steps here could work, could not work, could fail at some time, right? So what we would do, we will run the reverse step that we did, and this way we will always either commit or roll back and end up in a valid state. Okay, so that was about that. We do have some transactions that operate only on one site. Let's talk about what happens in steady state when we do not operate. So we know that the ZVM sends in and inserts checkpoints into the journals of your production sites, of your production volumes. And it starts off by sending the checkpoint to the protected site VRA, and the protected site VRA that protect all the volumes of the protection group will send it to the recovery site VRA along with the data that is being replicated. It arrives on all VRAs on the recovery side that are relevant to that protection group. And then the VRAs on the recovery side will acknowledge to the recovery side ZVM that they accepted that checkpoint. At the same time, the protected site ZVM, the production side ZVM, will send to the recovery side ZVM information on that checkpoint. This way, we close a feedback loop. And if all VRAs that are involved in protecting this protection group accepted and acknowledged to the ZVM on these specific checkpoints, then it is a valid checkpoint. So this is another orchestration that is part of the work of the ongoing work of the ZVM. Another thing that the ZVM does is that it monitors the usage of storage. It can happen that in order to maintain the SLA and the configuration of the history of the protection group, then we will need to acquire more storage space on the recovery side for the journals. So this is something that the ZVM is responsible and takes care of and monitors throughout. Later on, it can happen that there will be less changes and less replicated data. And after some time, the ZVM will see that we have the length of history that is required, but we're not really using all the storage space on the recovery side, so we can release it. So this is another thing that happens that the ZVM monitors and executes at steady state. Monitoring the environment, continuing on that theme. So we know that we are integrated and working in some environment, and we know that changes can happen outside of our reach. So what we do is that we registered to events that happen in the virtualization environments, such as vMotioning, some VM, or adding a volume to some VM, or resizing a volume. We are registered to all these changes that happen in the external environment to the VMs that we are protecting. Once such an event is triggered, we take that event and we send it to the recovery side, where we translate it into an updating of the protection group. By doing this, what we do is that we keep the replication intact and as configured while changes happen in the virtualization environment outside of our reach. On the recovery side, things are different. On the recovery side, the resources and the assets that we're looking at, that Zerto, that the ZVM is operating with, are recovery volumes, journal volumes, VMs of VRAs. These are all Zerto marked, Zerto managed assets. So in most cases, we know that these things should not happen. From our perspective, these are assets that we manage and we do not expect them to change. So in most cases, if changes occur to these assets, then we will translate it into putting the VPG, the protection group, into an error state. Another thing that we do is that we release and acquire the storage, as I mentioned, but I also want to mention that you can set, as you know, you can set the quota of the bandwidth that we are using. And we continuously receive the ZVM, when I say we, I mean the ZVM, receive information on the traffic from the VRAs. We receive information on the replicated data and such statistics. The VRA sends it to the ZVM. The ZVM summarizes this and watches for the fact that we need to operate within what was set as the quota of network bandwidth. If we exceed that, then we calculate how much was used, and we see which of the VRAs, according to its statistics, we see how much usage of the bandwidth it did. We prorate that, and we instruct the VRAs, each of the VRAs, as to how much network it can now use. And this is an ongoing loop. It can happen that we will lose connection to some peer ZVM, to some VRA, to the virtualization environment, and we try to auto-correct this fall of the connections. But it can happen that after doing all these efforts, some things we cannot fix on our own, and then we will trigger alerts in order for you to note that. The last thing that I want to speak about while being in steady state without operating the application are our internal processes. We receive all these statistics from the VRAs. We also have information that we collect, and together we validate that we fall within the SLA, or we know to set the VPG status. Another thing that we do on the background continuously is that we read information from the virtualization environment and translate it into our representation, because we want to be on track. By doing these things, by doing this caching, what we would do is that we conserve on operation with the external environment, because we have the correct cached information calculated once. Another thing that we do is that we calculate the UI screens that we do. By calculating them and caching them continuously, we calculate it once, and we don't need to recalculate it for every request from every endpoint. With that information, per each site, the ZVM does that. And then it sends this information to its peers, and its peers send it back to it. By doing that, this is the key enablement for us to provide the ability to operate the UI from either of the sites, so that you can operate the ZVM and see the same information from either of the sites. We're trying to be ready for action. But this is what happens in the background. But what happens actually when you start operating the application, right? So to answer this question, I want to invite Roie, my manager and friend, to take the session on.
So thank you, Gad. So we've just seen how the ZVM works behind the scenes when you're not actually interacting with it. Now we'll start and go into more details of how it. Sorry. So now we're going to see how the ZVM interacts when you do want to do stuff with it. And we'll start with creating a protection group. So when you're creating a protection group, what it basically does is we are selecting the VM we want to protect, and we need to configure the site, the host, the data store, the networks, all sorts of things that you want to configure, what it is how you want to replicate those VMs. And we are trying to make this simple. I think Rob mentioned in one of his sessions that it takes 17 steps to configure a VPG, but there are much more than 17 configurations that we need to do. And we are trying to simplify this on 3 basic concepts. One is to only show you what's relevant. For example, if one site is down, we won't show it as an available site for replication. Same goes for host and etc. The second is we're aware of what you've chosen. For example, if you've chosen to replicate to a VMware environment, we'll only show you the relevant stuff for VMware that you want to choose. And also, if you've chosen, for example, a host, we'll only show you the data stores that are relevant for that host, that are connected to that host. So we're contextually aware of what you've chosen before. And the third thing is defaults. We allow you to choose defaults for the VPG level. You can customize them and go into the VM level or the volume level. But by choosing defaults for the VPG, for example, of networks or data stores, it allows you to simplify the process of creating the VPG. Second, when creating a VPG is the validations. There are many validations that are running when you create a VPG. Some of the validations run in Wizard and are simple. For example, we want to make sure that the name of the VPG is unique. Some of the validations are a bit more complex, like making sure that the data store is connected to the host or that the data store has enough storage. The idea of the validations that we run in the VPG is that we try to make sure as much as we can that if we can fail the VPG creation, we'll do that so that when you try to do a failover, it will always succeed. So we'll try to validate as much as possible when we do the VPG creation. In terms of how the VPG creation is actually happening, so you always need to choose the VMs on the protected side, because that's where the VMs reside. But once you've done that, we move over the task of creating the VPG to the recovery side. It's always being moved to the recovery side, as Gad mentioned. Most of the operations in the ZVM run on the recovery side. Once it moves over to the recovery side, we translate basically the VPG configuration from a VPG, which is a host of VMs, down to the volume level. This is a translation that we do because, like Gad mentioned, the VRA work on a volume level. The granularity of the replication is the volume level. So what we do then, we interact with the virtualization environment and the VRA to start creating the recovery volumes and journals, which is essentially what comprises the VPG once we create it. This is essentially what we have on the recovery side. We don't have VMs, we don't have networks or usage of networks and things like that. And this is what conserves a lot of resources when you replicate to the other side. And last but not least, once we've created those entities, we persist the data into the ZVM database so that it will be persisted. And it moves over also to the protected side ZVM so that both sides are connected. So let's move over to the recovery operations. I'll go over a bit of a common concepts for all recovery operations, and then we'll move over to the operations themselves. So the first thing we do in almost all recovery operations is select a checkpoint. Not much to say about that, but we just select the desired point in time where you want to recover to. What's important to mention is that the move operation in that sense is a bit different than failover live and test. In move operation, you don't select a checkpoint because the checkpoint is being created once you start the operation and we shut down the protected VMs. this is a new checkpoint being created. In all recovery operations, we create a VM. What it means to create a VM. So like we said, we have journal and recovery volume being created or being replicated too in a steady state, which are connected to the VRA. When we need to create a VM, we spin up a new VM, depending on the platform. The new VM is being created based on the configuration of the protected VM and the VPG configuration, depending on what type of the configuration. We move over the recovery volume from the VRA to the new created VM. In hypervisors, we create a scratch disk. The scratch disk is what allows us to bring up the VM and power it on as soon as possible. Basically, every new write that the VM will do during its startup will be written to the scratch disk. And that's what allows us to bring up the VM very quickly. In public clouds, we can't do that because we don't have access to the drivers. And the beauty is that we can do that in each of the platforms. And it doesn't matter, like God mentioned, we know how to translate the VM properties in each of the platforms. So this is what happens when you create a VM. So when we create the VM, what essentially happens is that we create a virtual view of the volumes. So we have a VM, and we have 3 volumes attached or relevant to it. We have the recovery volume, we have the journal, and we have the scratch. The journal and the scratch are basically, the scratch has all the data that's once the VM was powered up. The journal is the last 3 hours, 5 hours, depending on your journal size. And the recovery volume is all the older data. From the VM perspective, it doesn't know what's happening. From its perspective, there is only one volume. It's a driver and VRA that knows how to mimic for that VM the fact that there's 3 actual volumes, but it's essentially only one volume. I won't go into too much detail into that, but there is a good session tomorrow by Oded that touches upon these points. But like I said, this is relevant for hypervisor. In public clouds, we can't create a scratch disk, and that's why we can't power on the VM as soon as the operation starts. So let's move on to the operations and failover test. So failover test is basically the ability to test your failover capabilities. When we start a failover test, we stop the applying of the data from the journal into the recovery volume. Because we are stop applying, and the test VM essentially has what I just mentioned, the 3 volumes attached to it, we block some of the operations on that test VM. For example, you can't clone it, you can't do storage vMotion or DRS and things like that, or any user action basically, because that test VM is owned by Zerto. One minute. The important thing to mention is that while doing failover test, because we stop applying those checkpoints and IOs from the journal into the recovery volume, the test time is limited by the amount of space you have in the journal. This is something that I know comes a lot in discussions, but this is what limits basically the test time. And it's important to mention because we never stop replicating once during a failover test. The failover test is running, but we keep replicating the data, so it means you are still protected while you're running the test, and it doesn't hurt replication. So failover live, that's the main thing that Zerto is comprised to do. That when you need it, you'll be able to do failover live. Because this is the DR operation, so it means we do not need the production site to be up and running. It can be under a hurricane, a flood, missile attack, whatever. We don't need the production site in order to run a failover live. We only need the recovery site to be up and running. Because this operation takes precedence and has the top priority, we make sure that any other operations on the VPG will simply be canceled out, and we'll start running the failover live. So if you have offsite clone, backup, JFLR running, we'll cancel those out, and we'll start running the failover live. And like I said, basically in the failover live operation, we're doing what I discussed in the common operations. So we select the checkpoint, we open up the VM, create the VM, and we bring it up in the DR site. So move is like the brother of the failover live, but it's a clear day operation. In move, we do need the production site to be up and running to start the operation, and we need it because we need to shut down the VMs and take a checkpoint. This is why we need the production site. But it has the same precedence, or slight less precedence than the failover live, but still higher than any other operation. We'll cancel out also failover test, JFLR, offsite clone, and backup, and start the move operation. When we finish, or when you commit the failover live and move operation, you have the VMs up and running on the recovery site. What happens next is a promotion. This is a task that can take quite a bit of time, and it's basically we take the data from the checkpoint you've selected and before that, and we start applying it into the recovery site, sorry, into the recovery volume. This operation can take a lot of time. This is obviously in hypervisor-based replication. That's where we have the scratch volume and the journal so that the VM will be up and running. But the promotion is something that can take hours or even days, depending on how much data you have in the journal. And this is the reason why, for example, failover test or live or move in a public cloud takes more time, because we need to do the promotion before we start the VM. Once we finish the promotion, that's when basically, from Zerto perspective, we release the ownership of the VM. Once we've done the promotion, the VM is now a normal VM in the system, and we no longer protect it. Last but not least, once you've done a failover live remove, you can do reverse protection. Basically, reverse protection is the ability to configure the VPG based on the configuration and some heuristics we calculate based on the VPG configuration, the protected VM configuration. And you can start the replication as soon as possible. So what we do is we take the old VM, with now the VPG has switched sides, we take the old VM recovery disk or disk, we move it over to the VRA and use it as pre-seed disks. We create a journal for that VM, and at that point, we can start replicate. We will start replicate only once the promotion has finished. And once we replicate, obviously, the VM is protected by Zerto. So this is the last bit of information regarding the ZVM and the workflows. So we'll do a quick recap before we move on to questions. So what we've seen today here is the ZVM and all the internal processes and things that run in the background to make sure that we are continuously replicating and protecting your assets. Next, we looked at some of the workflows, or the main workflows of the creation of the VPG, failover test, live, and move, and how they interact with the virtualization environment and the VRAs. And now, let's move on to some questions. So I invite Gad to join me, and if you have any questions, feel free. Yeah.
During a ZVM restart, whether it be an upgrade or some other reason, since the recovery VRAs are receiving checkpoints in their data stream, and I asked this question some time ago, and I was wondering if it would be possible for those VRAs, recovery ZVM, to clear up the checkpoints that you received during the time that you were down. That would
So,
yes, the data is all there. From the CSP point of view, you get a lot of questions from customers saying, does this mean you don't have my data? And actuality means no, you can't recover it completely.
exactly. This is exactly, you just answered.
Repeat the question just for the...
Okay. The question was whether during an upgrade of the ZVM, do we still replicate the data? Because if we do replicate the data during an upgrade of the ZVM, then why can't we, for example, fail over to some time during that upgrade process? So the reason is that we continuously, let's talk about the process of upgrading a ZVM, okay? So the ZVM that is being upgraded is at that point down. It's being upgraded. The VRAs continue the replication. They are different VMs, and they are a different application. They are not updated at this instance. So throughout the lifetime or the upgrade of the ZVM, there is no reason that we will not replicate, and we replicate the changed data. We replicate it to the recovery side. but we don't have the ZVM at that time. Since we don't have the ZVM at that time, we cannot insert checkpoints. So we have the data, only that at this time, we cannot return to the window of time where we were upgrading, because the windows of times that we can return to are determined by the checkpoints, right? So we cannot return to the point in time that happened during an upgrade of the ZVM, but we have all the information protected onto the recovery side.
We must have the feedback loop of the two ZVMs up and running for the checkpoints to be concluded.
The arrays know about the checkpoints. You can't, would it be possible to have some kind of button or something on the ZVM that says, load the checkpoints from the arrays from timeout down? Or do you still want
We do not, we just as Roie said, say you're upgrading the production side, no checkpoints will be inserted because we're upgrading it, so there won't be new checkpoints. Okay, so say we're not upgrading the production side, we're upgrading the recovery side. No one is listening and accepting and closing that feedback loop. So for this reason, we don't have checkpoints for the time of the upgrade.
It's the ZVM that gives the cadence of the checkpoints. It's not the VRA.
I thought there were the VRAs also had them, but not all of them.
Yeah.
A bandwidth optimization question. So, for example, 2 gig link between the two locations. As I understand it, there's 3 methods to configure replication. Unlimited, where it just pushes everything that it can through. Setting it to 0, where Zerto makes the decision of what the throughput actually is or what it thinks it is. Or setting it manually to 2 gig up to 2 gigabits. What would you think is the most optimal configuration?
Good question. Actually,
So the question was that there are 3 bandwidth options. One is unlimited, one is for the VRA to decide, and one is to set it to 2 gigs. And you're asking what is the optimal?
so if you have some set value, for example, X, like 2 gigs, then if you will be, there are some limiting factor to the whole process, okay? I want to maybe remind these things, maybe it's not that important. When data is being changed and the driver and the VRAs are looking after and holding and are monitoring and taking these changes and start replicating to the recovery side. So there are, I visualize in my eye that there are several points where you measure things. For example, the speed of your disks on the production side, and then a size of memory of buffers that the VRA holds in order to, because we don't hold the IO changes, we do that asynchronously, and then we send it to the recovery side. And when we do that, we have these buffers, and then you have the network bandwidth, you have the network and its bandwidth, and then there is the accepting VRA, which has also its caching and buffers in order to accept it and pull it out of the tunnel, out of the network, and then we write it onto the journal. Writing it to the journal, there is an I operation. So on the recovery side, there's another limiting factor, just like reading the changes on the production side or writing it to the recovery side. So these are limiting factors that affect the effectiveness and the speed that we can provide for our POs. But, so let's say there isn't, and there is, by the way, from cases, I'm looking at these people there, our support people, because they bust their backs over that sometimes, and looking and analyzing where are the bottlenecks and accepting that. So say, again, doesn't happen, but let's say that it does, that there isn't any drawbacks and any limitations of the IOs, of the storage there is, but let's assume there isn't, then say that you are, that the replicated data that you have never exceeds your 2 gigs limitation. No problem. But sometimes things sneeze, and all of a sudden you have this burst of IOs, and it will exceed. So then there will be a limitation. It takes us some time to keep up and reconfigure the algorithm that I mentioned. But that will be a limiting factor. Beyond that, I'm not sure about my answer. The VRAs, I spoke about orchestration and the monitoring that the ZVM does, and it does that. But each VRA, the implementation of the VRA is also optimized and optimizing usage of network, and you probably know that we can compress data for one thing, and also there is a question of what is the network window that configures the MTU and such issues, and how many buffers you have. So there are many things to tweak, and this is the way that I'm hiding and not giving you an exact answer.
So is it better to leave it in auto and let Zerto figure out what it needs to do?
Got it?
Yeah, I know. I'm looking at Ryan. Right. Yeah, quality of service. Yeah, I agree. Yeah, if you don't, yeah, a question of quality of service and yeah.
Wrap it up.
Thank you. So I want to, oops. Oh, it's there. Okay. I want to ask you to, we were asked, as all other presenters, to ask you to provide us feedback on this session, because using your feedback, we will focus the next ZertoCon on next year. So do provide feedback on the session. And also, I want to thank you for taking the time and allowing us to take you to the underhood of the ZVM, because it allows us to share with you our pride and joy in our product while being part in your IT resilience solution. Thank you.
Thank you.